Sneaky,
Oh,
sneaky beaky, like,
sneaky peeky like.
are we rushing in? Or
We're rushing in. Or sneaky peeky like. Good capitalize. Does it have sound now? Hello? 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 I think it has sound. If it started making sound here, then we will know. Give me a sound. Give me anything. Give me anything. Not that one. No, I know. You're being dumb. Just get the other one. Come on. Come on, hurry up. Do the other thing. You're so slow. Oh my god. You're so slow. Come on. That one. Yeah, yeah, that one. That one. Switch it. Switch it now. Does it work?
sneaky,
Oh,
sneaky beaky,
oh, there
like,
you go. Sneaky. It works. Okay, dope. All right, it works. So, okay, cool. So, last time, we were doing reviewing all the stuff that I wrote.
yeah,
So, let's go back to that.
yes, sir, yes, sir, yes, sir.
Okay, so scale the image. So, not this one, of course, not this one. All right. So scaling the image, that is just remapping a bunch of the points, right?
Yeah,
So we won't get too much into what all that is, but we just have a function that does it. But it's about moving the stuff.
does,
Okay, so talk about the grid system, gradation plane, why it's inverted, right? So do know that just for the, I'm not exactly sure because I mean, I think it's just why because computers are started off this way because you start off always from the top left point. Okay,
yeah,
that's why basically the Cartesian plane always starts from the top left point, and y is inverted, but x works the same. Okay, so I said that a couple times already, but um, in our game here, if we check that out, yeah, yeah. So we start in the middle, then it goes up, but like the beginning point's always up here, right? We know that. Redrawing the entire screen. Oh yeah, something that I find out as I was doing this, is screen flip. I'm not exactly sure what this does,
yeah.
but it works the same as update. So basically, it redraws the entire screen. I'm guessing it does something else. I thought that it might do like basically flipping the y-axis, just so it's like becomes the natural, the one that we're used to. But I don't think it does that. So I'll have to look a little bit more into that. So, okay, yeah, and how is it that I'm making that thing move is that I'm adding to the x value, right?
Yeah.
If I wanted it to move faster, I can add more here. But now, in the physics term, what does this mean? This can be boiled down to an actual equation that you will see later in physics, okay? So, what does this mean in like the more math terms? This would
Velocity.
be, yeah, velocity or
Or I forgot the equation. I was like velocity over time.
so velocity is equal to meters over time,
Oh,
or like
okay.
whatever distance you have over the seconds.
Yeah.
Okay, so or s divided or s over t. So s is for displacement, t is for time. Okay, so s doesn't usually mean seconds. Like we say m over s, that means meters over seconds. That way, specifying. I'm specifying the uh, the uh, the unit that I'm using, right? But here, this is basically saying like what is that I'm measuring, right?
Yeah.
So S is for displacement. Yeah. So, but understand here that in here, uh, X and Y both stand for position, right? So for that, we'll say like P is equal to the derivative of s over the derivative of time, right? ds dt. So the changes in distance over the changes in time, okay, at a specific ratio, right? And that is equal to a point, to a position that we're on. So you haven't taken calculus yet, but that is kind of what this means, okay? Why does it come out expressed like this? Is because the t is implied, okay? The time is implied, and the time is basically the tick, the FPS, the frames per second. Okay, so at this current moment, right, we could say that if we were to write another ratio here, is that what we have right now is that our velocity is equal to in the x-axis, or Vx, or velocity x, is equal to 1 pixel over 60 seconds. So you move 1 pixel over 60 seconds. As like you see in your car, you go miles per hour. And here you're going pixels per second, right? Every 60 seconds. Oh, no, 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 no. That's wrong. Every that would be very. That would be like every minute. So no, this is 60 times a second. So this would be this is wrong. So it would be 60 times every second. Um, how would I say that?
I mean, technically it is moving that fast, huh?
No, no, no.
Like on the
No, no, this is wrong. This is wrong. I'm saying this wrong. This would be like 1 pixel per minute.
right.
Okay? So what I should say here, uh truly it will like one way to express it would be 60 pixels every second. Every second. But that's not how it that's one way of saying it. Six because but there's a I'm going 60 pixels every second, but what I should be putting is I'm going 1 pixel every millisecond, or every 60th of a second. And I could say here every 1 divided by 60 s. There, better. And if we do this, so actually, yeah, look at that. So if we do this calculation, actually, um, let's do the paint thing.
Paint.net.
This one is better than the normal paint. I'll tell you what. Okay. So let me show you this real quick. So we know because it's based on this. This is very simple like physics, right? It's like the very but if you understand all these formulas, once you understand like what you were talking about, like how to do the more complex stuff, you need to understand these basic formulas to get into the more complex ones, right? So what did I just do there, right? So I'm saying that I'm doing 1 pixel every 1/60th, 1 divided by 60 every second, right? So how do I solve this? I multiply them and I I'm not so sure what this operation is called, but this will be 1 px over 1 tx, right? Times the inverted version of this. So 60 over 1 uh, seconds. That would give me, this will be equal to 60 pixels every 1 second. Make sense?
Yeah.
So that's one way to express it, right? So that would be the more math way to express it. If I do the second one though, if I do the second one, this I am doing. We, the important thing is that we can plug all of these ones here. Okay, so let me do the equation for the other one. So the by is equal to 1 px divided by minus 2 divided by 60 seconds. Okay. So what velocity does that give me? So if I run, and this is equal to bx, and if I go here, I'll do it again. So it will be 2 pixels, yeah, 2 px over 1/60th of a second. So, and I can change all these variables, right? I can change all these variables by changing this. So, for example, I can increase this, or I can increase this one to increase the how many repetitions I got every second. But obviously, I cannot increase this indefinitely because my computer has a limited amount of like frame rate it will be able to do before it blows up. You know?
Yeah.
It will probably won't blow up, but yeah. So this is equal to right 2 px over 1 is equal to uh the inverted of this 60 over 1 second. Like, not this. It's that. So this will be 120 is equal to 120 px per second. Okay? So 120 pixels per second. Okay? And that's my velocity. And this is equal to my Vy. Oh, and I did something wrong. Minus here. This is minus. This minus here turned into minus 120 Vy. So important. Can we have a negative velocity? Yes, we can. Yes. Yes, you can have a negative velocity. So, but you cannot have a negative speed, but you can have a negative velocity.
Oh.
So this is a concept of physics, okay? So let me explain this real quick. So let me get into that real quick so we can understand this because it's pretty important. It's pretty important. It's pretty important. New video.
Physics.
Yes, thank you, Professor Kata, for instructing me on this. See if I can help out a little bit. So there's such a thing as scalar quantities and vector quantities, okay? So scalar quantities is the ones that you're used to normally from like math algebra,
Yeah.
right? Actually no, that's not true because you can have plus or minus. And scalar quantity can only be a positive quantity. It's usually a scalar quantity is when you think of the absolute number of something, okay? So if you have like
Absolute value.
yeah, the absolute value, right? When you have this is equal to like 10, right? A, A could be equal to minus 10 or 10, right? So by that logic, right? So velocity is this one and speed is this one. Okay, so the absolute value of velocity is the speed. Okay, so the speed of your car, right, does not care where you're going. It just cares that you're going, right? So the little speedometer on your car, right, is just a gauge that goes up, right?
Yeah.
The gauge can go up.
Just step on it, right?
Exactly. You step on it, it goes that way. If you are down, it goes down, right? So, but what velocity measures is not only the it does not only measure this like the amount of your speed like that's the definition, right? Is like how fast you're going or right. It measures also your direction. Okay, so if I'm going this way,
Gyroscope.
yes, exactly. If I'm going to, let's say, the right, my velocity, but remember the b velocity, this is my positive 10 meters per second, right? And if I'm going the other way, okay, this is minus 10 meters
Yeah.
per second, right?
So backward.
Exactly. So importantly too, that's why in our program, depending of if the number is positive or negative, right? You go one way or you go the other way,
Right.
right? Because you're making your position, you're adding or subtracting from the position, right? And the position is just a number, right? So if my position is 10, or like, let's make this just 1 to make it simple. So if my velocity is -1, then it's gonna turn to 9, 8, 7, and so on, right? And if my velocity is positive, it's going to 11, 12, 13, right? So in the positive sense, I go one way. In the negative sense, I go the other way, right?
Right.
So that's that, right? So simple math, okay? So for simple physics per se, right? So keep that in mind. Okay, keep that in mind when we're developing a machine.
Yeah.
All right. So that's that. So some very simple things. Ugh.
How about sir, when you like jump or like bounce?
So we can talk about that. So what is cool about that is that we get to that by doing some more complex manipulations of the velocity, right?
Right.
So the velocity comes from acceleration, right? So if you add a manner of changing the acceleration that is controlled by you, then then what you said happens. So for example, gravity is a constant acceleration downwards, right? That's why I don't fly away, because every time that I jump, right, I'm accelerating downwards the entire time. Like I impulse myself up by me like jumping. I impulse myself up, right? Because I'm pushing, and there we have force.
Against gravity.
Exactly. So, but because I'm using a force to attack the ground per se, I'm attacking the ground, and then I go up against the force that is constantly attacking me from the gravity, right? So if we want to create those things that you're talking about, we need to understand the way that it works in our world. Because in reality, in a simulation, we can like do fantasy stuff, right? We can do things that don't really happen. For example, the thing that like you have a velocity and then you hit something, right, and then you stop. If that was the case, when planes are coming from the sky crashing, right, they would just hit the ground and they would just stop instead of like sinking into the ground and getting destroyed, right? Because when they hit the ground, they don't their final velocity is not zero. Voice crack. it's not it's not zero, it's their max velocity, right? Because otherwise they would just stop, right? So we do like the bounciness, right? We do talk about the bounciness
Yeah.
here, right? When we added the when we added gravity. We're not doing that yet, but so for example, so I'm talking about how we're like moving stuff, right? So what else? So what happens if we don't read all the screen? So I wanted to like how to like change all this stuff. I talked about the equations a little bit. Rubik's play, commenting out, screen that fill. Okay, yeah, I can talk about that for 1 second. So let me just stop the video. There you go. Sir, uh, it is important to also know, right? Like this is moving, right?
Yeah.
If I and it looks like it's moving, but it's an illusion. So if I remember commenting out, what does commenting out do?
It just stops the code. Like
Yeah, like it makes the code invalid. Like it makes the code so it doesn't execute. It's just a signal to not execute this code. So if that happens, so if we're not splitting the image, like the image does not, even though even though this number is still changing, the image is not showing, right?
yeah.
So if I change the flip here, it's redrawing, and I think that it's too. Uh,
So
so yeah, wait, actually no, it shouldn't do that.
look like
Let's see. I think it requires this, or is update the one that requires? Let's see. Same. It's flip or update. These both work. But yeah, whatever. So I'm gonna leave it like that. But yeah, that's about it for that part. Just knowing how to move stuff. I glad that I added that little bit there. Is withdrawing both on top of each other, pixels, fill, coming out a screen that fill. Oh, a screen that fills. So yeah, what happens if I do this? So if I don't redraw the screen, so I do need to update. Okay, yeah, that's what I was commenting out this thing. I always need to hit the update, but if I commented out then it doesn't get redrawn and then I get that effect, right? So so but that is happening, right? But what I'm doing clean up the screen every time is that I'm drawing over all of the houses that were there, right? So keep that in mind. Yeah. So that's that. All right. It's a cool exercise too to then make these things change based on conditions. So like making it bounce off the sides to do that little meme. So if it touches the side, then it's
Yeah, like
the screen bounce,
yeah,
right? So
yeah.
basically, all you have to do.
I have to
So
just put like from the aspect ratio of the screen, like the limit, like pending, like you would do like an if statement, you know?
yes,
Like if
but
they
what would
change
you
the top.
do? So, for example, we could come up with a little scenario here. So like, yeah, if like this X or this Y becomes the boundaries, right? Then what should you do?
You should decrease the velocity,
Decrease the velocity?
like for it to like go backwards, you know?
And how do you do that? Remember,
Collision
no. Remember, how do you make it happen? I just told you.
between.
So, to make it go the other way, what do you do?
Oh yeah, yeah, you go like negative. You
Exactly.
track.
You
Yeah,
you make it opposite.
yeah.
Okay. So let's do that real quick. Okay.
Yeah, so
Just to see.
no,
Okay.
because I mean collision would work. No.
Well, we do need a bit of collision, but I'm gonna do just the top one, right?
Yeah.
So if actually, well, the thing is that we need to set a velocity value. So I'm gonna add that to the pointers actually, so we can add that. GitHub be disciplined. That's important. Uh, wait, what? So
This is flying.
add velocity, add velocity injection. That's a good suggestion for something to do later. Like that would be like a homework,
Yeah.
basically. But yeah, well, we won't talk about that because the thing is that that's not within the thing of this, but that would be like a cool homework, I guess, for me to tell you. Like you have to make a variable, and then when it touches any of the borders, then you flip the sign of that variable, and that would make it. Don't make decrease it, just flip it. You know. So
Flip it.
yep.
Like literally flip it.
Like
Like
flip it as in like make it negative, or if it's
oh
negative, make it positive, right?
right.
You know?
Yeah.
So flip it from positive to negative.
Right.
Okay? Okay. So cool.
So would you just like overwrite the
The way to do it is to make a variable the opposite is
or you make two variable?
you just do exclamation mark.
Oh, exclamation mark.
Yeah, so like exclamation mark turns the variable. So
Oh
this
yeah,
would
yeah.
be like or like this would turn this variable to actually would it
That's actually a thing.
yeah.
Because
I think
usually the exclamation mark is like to say
actually I think in
not yeah not
in Python is not.
yeah
In other languages it's usually exclamation mark,
yeah.
but yeah, so basically I would say like
No, in Python you can't do not like with exclamation mark. You do equal exclamation mark.
well you can do this like y is equal to not y. So this will make it whatever the value is to just flip it. So if I run this, this should basically just make the stay on the same spot. Yeah, stay on the same spot because it's flipping from
Why not?
positive to negative. It's going positive, negative, positive, negative, positive, negative, positive, negative. Yeah, interesting that. So yeah, if you do that, then the y doesn't
Yeah,
move.
you
But
could also do exclamation mark equal or something.
probably does that work? I don't know.
Yeah,
Yeah, it probably works. Yeah. So cool stuff. But that's for a comparison. So
yeah.
All right, cool stuff. So, okay, so let's go to class. Oh, so now we're doing classes. So, so I'm gonna add that quick because that's pretty cute. That's a pretty cute little addition to this stage three. So a little bit of formulas. So stage four. Stage four, then we start doing classes, right?
Yeah.
So then we move away from that a little bit, and then we talk about the house, right? So I always talk about like a
Blueprint.
class. Yeah, it's a blueprint of a house, right? So could you tell me real quick what do I mean when I say that a class is like a blueprint?
Um, I mean, like a blueprint by saying like each specific thing that a house needs to be built from the blueprint.
Yeah,
Like,
that's
yeah,
that's
like
pretty
a
good.
specific thing that
So
you
when
need to
no, go
make a
ahead.
blueprint. Like I don't know, like color or whatever
No, yeah, that's good.
size.
Or better said is that the house will have like a specific color for the walls,
Yeah,
right? So the walls will have a color. Then maybe it has a default color, but you can also choose what color that might be. But you know that it will have the property of having a color,
yeah,
right? So it describes the things that that a house could be, right? And they could be also subject to change depending on how we create the class, right?
right.
But what is it outlines what it could be, but you do not interact with it, right? So class is just the object, like the blueprint that you outline, but you do not interact with, right? So oh yeah, im- so what is RAM? Do you know what RAM is?
Yeah, 16 gigabytes.
16 gigabytes of RAM. But what does it mean for your computer?
Random access memory.
Render access memory, right? That's there,
Random
but
access memory. Yeah.
memory,
Yeah.
yes. So, but what?
Basically, from what I understand, like like the basic part of singing is like it allows uh like depending on the space it has, it allows you to open more apps, more heavier programs, with like more tabs.
True,
Like it lets you do it.
true.
It's, I don't really understand like the whole thing. I just know it's like it just lets you access like it stores it like it stores it temporarily. Like it stores stuff temporarily. That's what I understand.
That's good. No, that's a good understanding. So if you want to do like electronics, you will. I guess this is like the pre. This ends up being like even almost out of the electronics realm and more
Yeah.
into the computer science realm, but it's pretty important. But what it does, it creates like the short-term memory of the computer, but more or less it creates the working memory of the computer.
Right.
Okay, so when the computer needs to work on something, it does not go to the disk drive to read that value and then spit it out to you because that takes too much time. Okay, because and even now it's faster than it used to be, but back in the
Yeah.
day, imagine you have to physically spin up a disk, right?
Yeah.
Spin up a disk and read from that disk.
There was an
Okay,
M.2.
yes, exactly. But either way, it's still faster to read from like almost like a digitalized version. And do you know, have you ever seen how like I went to the NASA space station, and in there they have like some of the like super old computers,
Supercomputer.
not supercomputers, like the old ones. And
Hold
the way that they like store memory is with circuits, right? Like they would have like I don't know the exact name, but they would have this like electronic things that a current would pass through them, and it would be like the high or low, right? And depending on the high or low, it would be 0 or 1,
Right.
but that was the memory, okay? And that's the memory that the computer uses.
Yeah.
It is not like a physical like written thing. So like you can think that like in the disk there's like very small etchings that like the computer has to like scan and read, right? And then turn those into like those digitals, like digital high or lows of the electronic signal, right? To read the memory. So that takes a lot of time.
Isn't that like a hard drive?
That's the hard drive, yes.
But the
But
hard
and
drive still like it's like mechanical stuff. Like
well, yeah. So yeah, you nowadays you don't even have to deal with those. I have to deal with those
I'm
back
not
in. Yeah, exactly. So like the mechanical,
I'm
exactly.
not too worried saying.
Well, those are the cables, but yes,
Yeah.
but those but yeah, you're correct. So basically, you would have this thing that spins, and then like that's how you store information. Uh, and I still use some of those for like storing like mass information
Yeah.
because it allows you to store a lot of stuff,
Yeah.
right? So, but yeah, so but more or less, yes, you have your RAM. So now for all your programs, right, you're usually operating on the RAM. And you can think about this is interesting because like I look at my program here, right? The program like this program as it's written like this here, okay?
It's RAM.
This no, it's on the hard drive as it's written, okay? I'm saving it on the hard drive as it is like that, right? But the second that it runs, the microsecond that it like a nano, a small amount of time that it runs when I make it run, and it just like it runs super fast on my computer. During that moment, it was on the RAM. Okay, the computer read it from the disk, then it put it on the RAM, and then it executed it, and then it's done with it. Okay.
Yeah.
In this case, it doesn't. It's never done with it because we tell it to keep going because it's a game, so the loop keeps going, right? So we keep telling it to like go over and over and over and over again the game, right? But in for like all the other programs, like basically you go one, it goes into the RAM, it reads like the computer reads from this program from the hard drive from this program, right? Puts it on the RAM. The RAM, the processor executes from the RAM, and then it's done. Okay, so and that is like super fast. Okay, yeah. Uh, 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 uh.
How many gigabytes of RAM do you have though?
On this, I don't know. I mean, if you want to check, you just do
No, yeah, that.
device manager.
Oh,
Device manager. I think you can do it from there too, right? But you here processor, the storage devices. It's not the storage, so like this is the which one is far more computer operating
still, actually, I don't know. I've never gotten that.
device?
I think it might be the computer.
It's not this drive. This is the hard drive. There are more human devices and more other printers kitchen so phone audio blah, 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 blah.
Computer.
Maybe
No.
no. I think you might
Task
be more
manager.
right than I am right now. Yeah, task manager.
Yeah. Yeah. So wait.
That is the way.
Yes, sir. And then you go to
Memory. So this memory, damn, let me say all that. Yeah. So this, for example, look, the disk. This is like the hard drive, and
yeah.
this is the RAM.
RAM. Yeah.
It's because I'm said
Google Chrome
Google
thing.
Chrome is eating all my RAM. But that's just typical. That's just how it is. I think that if I go here, it tells me.
Yeah, 16 gigs.
Yes, 16 gigs. So yeah, that's pretty normal for a computer. Okay, whatever. Let's not get too much into it. Okay, yeah. So, but now, so you can think about that too. So, with that analogy, right? The class lives more or less on the hard drive. Okay, the class is like this hard copy that you don't touch that much that lives inside of in this place, and then the the objects. Okay, all of the objects exist on the RAM because they are all creations from the this entity on the hard drive that doesn't get manipulated much because it just exists and you just read from it over and over again, right? And then you create all these more like short-lived objects that serve a purpose and then they're gone. Okay, um, in the same way, right? Like a house has uh, an address, right? You assign a memory address to your objects, okay? And that's not automatically by like the programs because that's like a very drilling program that got automated a long time ago, right? But basically, every time you create a variable, you are assigning a plot of land to a piece of data. Okay, what that piece of data looks like, it could be just like a number or like a letter or anything else, right? When you tell it that it's going to be a class, then it knows that it's going to be like a bunch of these sets of data and it knows how much to allocate to these sets of data. Okay?
Right.
So that's what the class is, right? Uh, well, I talk about kind of lose like that, discuss characteristic, what's an object. Like, yeah, the object is like the house itself that exists within more or less the RAM. Uh, how is it gonna? Yeah, you can. The object is the thing that you interact with, right? The object, if you want to change the color of the house, you can go and paint your house. If you want to turn on the TV, you can turn the TV. You want to open the door, you can open the door, open the windows, do or turn on the stove. You can do whatever you want, but to the object, okay? You interact with the object, not with the class, okay? But you do need to add. So, for example, how can you open a door if there's no door? Right? So there that the fact that there's a door that's described by the class, right? So that you can open or close the door that is described in the class. So the function of opening and closing the door, right? That is in the class, but actually opening or closing the door that is in the object. Okay, so the function is described in the class, the action of actually making that happen, that is in the object, right? Remember that.
Yeah.
All right, so and aliases. So this is an important thing too. It's like what's an alias? So the alias is like the name of the variable. Okay, so and you can choose that, right? So for example, I say like Juanito's house here. So you don't describe like the house of your friend as like 11625, blah, 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 you know. So what you do,
Juanito.
yeah, you say like I'm going to Juanito's house, right? So the computer does understand that by saying like this variable is called like A, B, or C, right? But the computer knows that you call it A, B, or C, but what the computer knows that you're referring to this spotting memory. Okay? Okay. So and then you have like the formal structure. This will they will teach you in they will teach you in like the programming classes, but they show you this like a class, and then the class has properties, which are in the constructor function, and then you have functions, which are the things that you interact with, right? So that's that. So create a class. So we did about this also. So the image. So for example, when we talk about this, uh, in here we have the house. All of these are parameters, so that gets talked in the next section. But this is very important to understand what this does. But yeah, this is the parameters, and then from there we do a bunch of stuff. So let me just check what I say here. So we create the class for house, uh, position, size, and image. So those are the parameters that we're asking for. So we're saying that to create a house, we will need an image of the house, then we'll need a size for the house, and a position to put the house in. Okay. Then those we assign to the core values of the no, the properties. They're called the
Yeah.
properties, but those are like the inside values within the object. So every object has values inside of itself that are different from other objects, right? Or maybe they be the same, but like they could change. And I'm more than likely they're going to be different, right? They share the same structure, right? But the values are different, right? So you can have one house that is yellow and one house that is red, right? You know that they're both houses, but they're different colors and they're also in different positions,
Right.
right? So when I say self here, I'm talking about those inside values, those properties, right? They talk about I'm describing them inside of the blueprint of the house, saying that each house will have a different image, a different size, a different position, right? They could be the same, but they are. But we could say that these things are the things that vary. Okay. What doesn't vary between them is that you will get an image, you will load the image, you will put it inside of this, and then you will transform it based on the size. Okay, that does not vary between any of them. They will all do this thing here, right? What will vary is the size. So like if you send a different size, it will do a different size, right? All right. And then I declare, right? So here is the DACA house, like that's my house, Felipe's house, however you want to call it, right? Like that's the nickname for it, right? And it comes from the class house, right? I send it a size, which is 100, 100, and I send a position 400 by 200, and then I write
Like on this decision.
right. That just appears there, right?
Yeah.
So we get the same thing. This one doesn't move because we have not added that makes a move, right?
Yeah.
In this other part, right? So we have the running, yada yada yada. In this, we just draw the house, right? In the continuous loop, the house just gets drawn. Nothing else happens, right?
Yeah.
And that's that. Okay. So that's that for that. Uh, bugs can happen. So yeah, oh yeah, this I do want to say. So well, I'm not doing this like with you right now. I'll do this when it happens. But basically, yeah, when you're doing this by yourself, there usually a lot of errors come from this when you're first doing it, and they usually come because you didn't use self or things like that. So error handling more or less like that's why I make it. I should turn this into black. Look, read the error. No one reads the error. No one ever reads the error. Okay, you say like, you see this big block of text? Yeah, well, the block of text is telling you that you're wrong.
Yeah.
Like, and you can, and it will tell you how you're wrong. Okay.
That's right.
It's a yes, but I mean, no, not always. Like when you get to the more, this is pretty simple. So, like, if you're these are kind of rule of thumb, but when you're just starting and it's the beginner stuff, the computer knows better than you.
Yeah.
Okay, if you're doing some like heavy metal crazy stuff, then the computer is likely to maybe do some like edge cases that it doesn't know. But if you're messing up, you just read the error and look at what the error is telling you that is wrong, and you will be able to solve that error pretty easily. Okay,
Yeah.
because because it is more likely a common error that the developer of the programming language already addressed, right? And they say like, oh, you cannot do this, you cannot do A because of B, and it tells you that logic, and then you just correct B, and then A works. You know? So there you go. So uh, if the console usually flushes the trash can press, oh yeah, okay, so now I say that it it's good, but Python does mess up sometimes. So you can flush it because sometimes the console becomes useless because it comes too cluttered, and there's like some back propagation errors that yeah. So how do you do that? Basically, do this. So you have the console like this, and it gives you a bunch of errors. You just like use the trash can and close it. Bada bing, bada boom. And then to reopen it, you just do Control tilde. Tilde is the thing right below escape. No
Control
one knows
T.
what.
Control T. No.
No, Control tilde.
Oh.
Yeah, no one. You don't use tilde in English, so no one knows what it
Yeah.
is. But it's basically the thing below escape.
Yeah.
Okay. So yeah. Yeah. All right. So good with that. So functions. I even did a little graph for this
Yeah.
because they're so important.
Similar.
So important. But no. But this is the same as as the math functions,
Yeah.
right? It's the same as the math functions. When I first started like programming, I never got into this because I hated math back in the day. But now I like it a lot. But they operate the same. And if you get really good at programming, you can basically skip all math in a way. But I mean, kind of you still need to understand it, but like you get to skip like the grueling process of like doing the whole thing. Some professors might disagree with that. As long as you know how to do it once, and then you can make out your. I would say if you can make a program for it, you know it well enough to like not need to do it anymore.
Yeah.
Like because if you were able to write the program yourself, you understand the process of how to do it from beginning to end, okay? Well enough that you can tell a computer how to do it. And if you can tell the computer how to do it, then you should just be able to like, you know, like make the computer do it. That's what it's here for. Maybe it makes you more dumber because I mean that's what they say. Don't use calculators because that's essentially what calculators do.
Yeah.
Uh, but in reality, calculators are able to like. I mean, if you're able to do what a calculator does, really, you are like in calc 3, like very far ahead because uh, calculators deal on series, which is like the edge of the edge of the edge cases of mathematics, right? The professor describes it as the ceiling of mathematics. If you cannot solve it with series, then you cannot solve it, kind of, right? So basically, a calculator deals on that, and if you're able to program that, then you are like your algebra is basically, you know just delegate it to the computer. you are, you're him. Yeah, but whatever. So I okay. So due to address this is that there is this discussion for programmers, and this is only for like giga nerds. But like, I mean,
I
the
think
thing is that
object-oriented programming.
you because you haven't done functional no, object programming function. So no, no, not
That's what I was doing before. Wait, I learned
function. Wait,
object.
no, object. No, I'm function oriented programming. This is so badly function
This is what I was learning how to do function-oriented programming.
Yeah, well, function oriented programming is basically tells you don't do any abstractions. Just run everything with
Yeah.
direct functions. And if you don't do it that way, then you don't have the brains for it, and then you should just like that's what they would. That's what like the very militant people that do function like only functional programming will tell you. Uh, say, listen, buddy.
Showing.
Actually, well, they use object-oriented programming like industry-wide. Okay, they use it like in all the very like the things that require like heavy reliability, like a lot of business programs and a lot of like that stuff. They do it on object-oriented programming because it's easier to understand, and the more people that understand it, the easier it is to debug, the easier it is to like to test for it, better say, right? So it's like, oh, you're a good programmer, then but whatever. So, but truly, okay, functional oriented programming is usually more efficient. Uh, like meaning that like it takes less space, it operates faster. But object-oriented programming is closer to our language and is easier for us to understand. So yeah. So a debate for like that still goes on per se, but yeah, so know that. So now basically what they will tell you to do is basically just program using
Yeah.
functions. Okay, so I'll explain what functions is. Object classes have functions, right? So how does a function work? Like functions
Functions are easy.
well, yeah, but like you gotta think that functions are like your little factories, right? And you do want to use functions a lot in programming. Okay, you want to abstract a lot of stuff, put them in these. If I remember quotes, I'm probably not gonna remember the exact quotes, but like, and I probably should reread this book. But Clean Code is
Okay.
yeah, programming book that I read. Clean Code that is heavily cited is that functions should just do one thing, okay, and do it well, okay? And that means that you name it and you give the function a name, okay? And it only does whatever that name is, okay? It only does that, it does it well. And then if you write a very for example like what they always warn against is that like you write a function that does like 8 things, right? And then it becomes impossible to debug.
Yeah.
Because you can write a function that is basically like read and write and draw and scrape function, you know.
Oh, like using the like the and but like
No, no, not the and operator. So like
no.
you literally write it like that. Like you literally write it like this. So like something that they would say is bad principles of programming would be something like this. Look, uh, here. So I guess I put, so for example, I have this set position, draw position, set position. So this I'm putting the position to this place, right? So, but look, yeah, this is a simple position. But like a bad function, an example of a bad function would be like set position, draw, uh, set position, draw. Uh, hold on, you're so fascinating at uh, set position, draw, uh, jump. I don't know, like so if you want like a jump thing and it requires all these other things, so like set position, draw and jump. So if it requires all those things, you are doing something wrong. Okay, like you know that like when you're trying to describe your function, it requires these many words, then you have already messed up like a while back. Okay, so what it should do, it should be like, for example, the draw. Okay, what is draw supposed to do? Okay, uh draw you're supposed to draw, right? So for, and what I usually end up doing in this thing is I do like the update, so like def update, right? And what is the update supposed to do? The update relates mostly to the physics part of it, right? And at the end of the update, you draw, right? Because you need to update all your physics and then you redraw at the end. But I don't, because I wouldn't say like update, then, or like update then draw, right? Or I mean, I guess there could be a way because you could just do update then draw and then like call it. But I won't get into that thing. But basically, like update, draw, and then all this stuff. But but yeah. So not to be too pedantic about all that stuff, but like yeah, that's some of the stuff. But like this is a function that we are doing here. We're setting the position and we're setting the position to an increase on x, right? So I have an x variable here, right? I have an x variable here and I'm making that x equal to x plus 1, right? So this is giving me a velocity of how much?
Um, what do you mean, like how much? Like how much are we adding to it?
Remember that I gave you the little equation that said uh how much
Velocity equation?
Yeah. So how much would it be? Do it by the little logic. So you're increasing
Right.
one time, and then you have 60
Yeah,
repetitions.
it's I think it was a one, no, 60 over one, like
So that would be 60 pixels
60
every 1
pixels
second.
every 1 second.
You're
Yeah,
correct there. Yeah.
60.
But you gotta remember, say the units. Okay.
Yeah.
So 60 pixels every 1 second, right?
Yeah.
So the velocity is 60 pixels every second, right?
Second.
Yeah. So like meters per second, miles per hour,
Yeah.
that's the same thing.
But
So
pixels.
exactly. So now how much is that going to move?
How much is it going to?
All right, well, how is it going to move?
It's gonna move horizontally.
Yeah. Where?
Uh, where
We're gonna move horizontally, but what side? Like left or
what
right?
side? Oh yeah, to the right.
To the right.
Yeah.
I think you're correct. There you go. Yeah, it's moving to the right. So it's moving to the right at a rate of 60 pixels every second.
Every second.
Okay, so might seem like it's pretty fast, but that's how fast it is, right? I can double it, and I can also like do like 1.5. So for example, if I do 1.5 here, it's gonna go like at 50% the speed. So
Yeah.
speed 1.2 is well, 20% speed. And for example, in here you can do multipliers. For example,
Yeah.
so like I could do 1 or plus 1 times how would I do this? What would be like a cool way of doing this? Uh plus 1, maybe like
Times something.
1 plus mult. So I can do a multiplier here. So mult equal to 0.2. So that would be, I am going at 20%, like 120% speed.
Yeah.
Okay, so 1 plus 0.2 is 120% speed. So it's going to go 120%. So there you go. It changes to 1, this is 200%. So there's going to be, or if I change this to like 5, this will be 500%. Very fast. You know? Pretty cool, pretty cool, pretty cool. All right. So I think it's too stuck into that. But that's like one manipulation that you could do. You know?
Yeah.
All right. I don't want to know. What did I do? Oh yeah. I don't want to change anything here, really. Ah! What did I do? Okay. I don't want to touch it. Ah! Okay. Cool stuff. All right. All right. All right. So that is that for functions. So advantages, yeah. Uh, most important, simply, yeah. So yeah, functional functions, think about
Like
math class
that.
and first a little bit. Yeah. Okay. So what does it mean? Yeah, 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 yeah. So well, I could talk about this for a bit, but I already talked about it in a way, but like, well, what does it truly mean, right? Like, let's think about what does it truly mean.
Yeah. Basically,
Yeah, so this would be x is equal to x plus 3. That's what
yeah.
the function means, right? So this the function is equal to x plus 3, right?
They give
So
you
but x could be something else, right? So x could be like, yeah, x is 5, so it's 5 plus 3. So f is equal to 5 plus 3,
yeah.
8, right? So that's what the function is, right? So you can think that it has like an alternate, like x has the fx value, which is an alternate value based on the value of x, right?
Yeah.
All right. So like factory, right? So you have the the 3 value. This is the x value, right? You have the f of x. F of x is the function. Is the factory, right? You grab that 3, you put it into the factory, and then you get a 6, right? So f of x ends up being equal to the 6 here. So like you raw material goes into the factory and then gets turned into a phone, right? So always think about the functions in that way, right? That's what all functions are. Even like, when they say like the function of like this, that, and so, when they create like graphs, right? Those are essentially like the function spin up many, many times over like with different x values, right? That's all what functions are, right?
Yeah.
So then we have, so how do we do the function? Functions. Uh-huh, uh-huh, uh-huh. So in here, you're supposed to do this yourself, right? So on the side of the function, using the self keyword, explain self keyword, right? I'm referring to the instances, right? That it can be different for everyone. So if I had two houses, right, I could change the position individually of all those two houses. So I could do that right now, real quick. So if I want to make another house, so I have the DACA house here. I'm gonna make
Pika house.
Pika house. Pika house is equal to
Yellow.
house, and then I need to send the same thing. So I'm gonna say house dot png, comma, the size. I can change the size. So I'm gonna make this. How big is the other house? So I make this house maybe a bit bigger. So I'm gonna make this like a x is gonna be the same. Then this other x is gonna be 200, and then the thingy here is going to be better said. So the x should be the same. So let's not put on 402, comma, and this is gonna be 800. Does that look good? Yes, that looks good. So it has a different y, same x. Uh-huh, uh-huh, uh-huh.
Sir.
For this, x, y, and y2 is going to be equal to 800, just because I need another one for that. So the two things I need, right? I do need to draw the house. So pick a house dot draw. I don't need to draw it, so it shows up. So now it's not gonna move. It's not showing. Is that not?
I think it's too far.
Could be.
It's
Uh,
off the aspect ratio. I don't know.
I don't think it is. So the let's see what it size position. Position is 400. Wow, pick a house. Oh no, yeah, you're right. Maybe it's off the charts here.
Yeah.
Oh, you're right. You're probably right. Yeah. Oh, yeah. There it is. And it's kind of wacky because it has
Yeah.
the. Let's put it instead of 600 to 500. Change this one to 500. Good catch there. I didn't catch it myself. Oh, there you go. Right. So it's here. So now, if I want to make it move, I can do the same set position here. So control Y2, and I do the same with X. They will move at the same rate because I'm setting them to X, right? So this is going to be interesting. So they basically both, right? They're both going to be moving at the same thing.
Yeah.
Oh, that house. Oh, look at that. And keep in mind, look, so because I called DACA house, right?
Yeah.
I ended up just moving this one two times, right? Pika house, there you go. So DACA house, Pika house.
Yeah.
You see? So they're both moving at different things and they both are kind of different. So,
Yeah.
pretty cool. So this only happens because of the self, right? Because I'm calling function, I'm calling the same function, the set position, and the same position here. So now here is where, like, if I wanted, so let's think about that. So if I wanted to do this on a functional approach, right? On a function-based approach, I would have to also send what object I'm moving, or I wouldn't even have an object. I would have like some data point. So like I would have like there may be better ways to construct this, but like basically, I would have like something kind of actually like this. I would have like a position, like DACA position would be like DACA position X, DACA position Y, and then my function would be like increase, and I would send like DACA position X, and then comma increases by one, and that function you would just run. Okay, but I would have to send the variable that I want to change. You know, in this one I don't have to send the variable that I want to change. The variable is implied because I know that it's the x value inside of DACA house. Okay, so I don't have to like actually express it because of the object-oriented approach. It's already there. So that's one of the advantages. Oh, I'm already over the time. So, well, that's about it for this. Do I have anything else? So, yeah, self, you will not see self in function-oriented programming. Okay, you will not see self. So, only in object-oriented programming you'll see self. Okay? So, well, that is it for that. Hope those were useful. We'll go over the next part soon, and we're almost done with like the review, so we can go back to what we were doing the other time.
Yeah.
So that's that. Okay. Uh, Stop the stream. Thank you for the people that are here. You guys have a good one. Two on YouTube, one on Twitch. Interesting stuff. All right. Thank you guys for tuning in, and I'm